Good morning, and welcome to day 5 at reInvent. I want to begin by thanking you for choosing to spend your Friday morning with us. I know you're a very passionate bunch. It is the only possible explanation to spend your Friday morning listening to Web3, payment protocols, digital assets, payments, and agentic payment. I don't know if I would have made it here, but I applaud the curiosity. In addition to being grateful, I'm very excited today. I'm excited because we are joined by our customer, Coinbase, who will also share their journey with agentic payments on AWS. Before I begin, I would like to understand a little bit about the mix we have here in the audience. I walked around and talked to some of you, and it seemed like some of you had some background on Web3 and some don't. It'll help me understand who has, the mix of the crowd, so I know how much time I can spend on that. Can I see a show of hands? How many of you are actually building actively on Web3? Okay, very few. So I will spend a little bit of time giving an overview on Web3 and digital assets, so you get a deeper understanding of the topics that are set to follow. Okay, my name is Arvind, and I will be jointly presenting this session with Joshua Smith, Senior Solutions Architect at AWS, and Eric Rappel, Head of Engineering Coinbase Development Platform at Coinbase. So what are we going to talk about today? I'm going to start by giving you an overview of Web3 as promised. I will spend a little bit more time than I originally planned to, so I can set the stage for you on what is Web3, how does AWS see it, what is our perspective on Web3, what are some of the workloads, how do we address the requirements of these workloads, and what do we have planned as we move forward. We will then segue from there into what digital assets can do for payments and why they matter. After which, Eric will come on stage and talk to you about X402, an open source payment protocol. And that'll be followed by Josh's talk on how to implement agentic payments on AWS, leveraging AWS's foundational capabilities with X402 that Eric talked to you about prior to that. Sound good to you? Okay, so that's what to expect from the session. This is a 300-level session, so in addition to the overview I'm about to give you for the people who are curious, we will get a little deeper into the code and into the implementation. All right, so Web3, what does Web3 at AWS look like? What's our perspective? When I say Web3, how many of you immediately think cryptocurrency? Now I see more hands go up, right? For good reason. Crypto has been probably the most popular use case over the last 10 years for Web3. So when we say blockchain, when we say Web3, people immediately think crypto. I'm here to tell you that our view of Web3 extends far beyond crypto. There are a lot more use cases that take advantage of the same foundational principles that underpin Web3. Crypto is just one of it. There are many decentralized applications that take advantage of these different technologies that we're going to touch on today. Web3 came about in response to the perceived shortcomings of the current internet infrastructure, with the core tenet being decentralization. There are a variety of decentralized technologies that need to come together for you to operationalize a Web3 workload. Blockchain networks, decentralized storage networks, virtual machines for smart contract execution. So if you're thinking about an actual use case or a workload, say to bring a digital asset to life, oftentimes you're pulling together a lot of these decentralized technologies to operationalize a single workload. That's really how it all comes together. And when you do that, you have a lot of choices to make. And we at AWS are here to provide you with the prescriptive guidance you need to build these workloads and deploy them at scale. So when you think about building a Web3 product, using decentralized technology is not the goal. It is just a means to an end. At the end of the day, you're looking to build the product. So in many ways, it's incumbent on us to make sure we are providing you with the right building blocks so you can take advantage of these technologies and build the product you need. We are in the business of providing these primitives, of these building blocks so you can build the Web3 products. We don't build the Web3 products for you. You're doing that. What we do is bring all of these foundational technologies and primitives so you can go and operationalize these workloads. But as you go about doing this, taking all of these decentralized technologies and building that Web3 product can quite often look like that squiggly curve you're seeing on the screen. And that is so because you have a lot of choices to make, a lot of components to take advantage of, to pull together a single solution. The most foundational choices you will make are around first choosing the right foundation to build your products. Are you going to use a public or a permission chain? And are you going to use a mix of both? Which public protocol are you going to choose? Are you going to choose multiple different protocols? And if you do that, are you going to have to build interoperability? And now if you're talking about assets, are you going to provide custodial solutions or non-custodial solutions? How are you going to handle your smart contract execution? What kind of standards are you going to use there? These are all topics that you may or may not be familiar with, and these are a lot of different choices to make. And once you've gone past these foundational core components, then you get into other choices you have to make. How are you going to handle your blockchain data? How are you going to do the analytics? There's on-chain data, there's off-chain data. How are you going to bring it all together to make the choices that you have to make when you build your product? How are you going to build your wallet? Are you going to build it or are you going to buy it? And of course, if you're involved in the digital assets business, are you going to be an issuer? Are you going to take care of that yourself, or are you going to leverage somebody else to do that and go off to build the product you need so you can remove the heavy lifting from yourself? These are very big choices to make because they inform how the business is going to progress from there. And this is where we come in. With the approach that we have taken for Web3, we take that squiggly curve you saw and do our best to make it that straight line you're seeing on your screen. And we are doing that with our three foundational pillars: managed services, do-it-yourself Web3 solutions, and a very robust partner ecosystem that we have built around Web3. Let's start with managed services first. If you're looking to build your own products on AWS, you could take advantage of all of the primitives, all of the building blocks that we have today and operationalize your solutions. You could do it all by yourself if you chose to do it. It is a lot of work, but it's doable. All you have to do is take advantage of some of the core infrastructure products that we have, and we help you build it. Now, from an infrastructure perspective, let's focus a little bit on EC2. I do have Lambda and other logos over there, but I'll take a minute to talk about EC2 here. One of the core tenets, as I talked about earlier, is decentralization. Decentralization does not mean you don't run on the cloud. It only means you're decentralizing the authority or the decision making. Now, when you're thinking about running nodes, blockchain nodes on the cloud, AWS offers you a certain assurance by default, which is there is no operator access to any customer content on any Nitro-based instance that's running on AWS. So now if you step back and think about one of the big things that probably drove you to think about decentralization, it's about that access to data. It's about the ownership. And with AWS, if you're spinning up an EC2 instance and running it, by default, there is no mechanism for any AWS operator to access your content. So your content remains protected. It is perhaps one of the best reasons as to why you should run your blockchain nodes on AWS. There are other components as well from storage and security. I'll touch a little bit on security now. If you're building custody solutions, I highly encourage you to think about specialized capabilities that we have built specifically to address these Web3 custody solutions. AWS Nitro Enclaves, it's the foundational component for confidential compute on these wallet solutions. And if you're using enclaves, you're perhaps using a key store to bring your keys, to decrypt them within the enclave, to manage the keys, to sign your transactions. We have products like AWS KMS and Cloud HSM that allow you to do that. And I'm more than happy to take questions about it after the session. We can deep dive into what that looks like on AWS. I'm just leaving you with some components and products to think about as you start thinking about these specific solutions. In addition to managed services, we also provide certain do-it-yourself solutions. These are not production grade, but these help you hit the ground running. We have built what's called AWS Blockchain Node Runners. It's an open source project. We have blueprints for several popular protocols on node runners. And this helps you spin up your own blockchain nodes on AWS. So if you're looking to self-manage your nodes, if you're not using a provider to do it for you, you could directly use EC2 to spin up your blockchain nodes on AWS, and Node Runners helps you do that. It provides you with the blueprints. And we continue to add popular protocols to Node Runners. So if there are protocols that you care about, you don't see it in our repo, talk to me, send me a note, we'll add it, right? Another solution is around blockchain wallets. We've been working with blockchain wallets for 4 to 5 years now, so we have a lot of knowledge on this. We have a lot of expertise we have built, and we have shared all of that. We have workshops on blockchain wallets. We have blogs. We have prescriptive guidance, architecture guidance on how to build wallets on AWS. Another big program that we run for Web3 is the AWS public blockchain data. We provide blockchain data sets for free. We choose the top blockchain protocols that customers most ask for or care about. We monitor the activity to see which protocols we need to keep adding, and we add data sets for free. We've been able to do this through partners over the years. And as we move into 2026, we're taking a minor shift in the approach, and we're going to work directly with the foundations to bring you data sets from the foundations. So you don't have to rely on any partner products. We'll provide it for free for you, and it'll be available through the AWS Public Blockchain Dataset Program. Let's take a quick look at these node runners. I have the QR code here for those of you who care to look at these blueprints. We have added support for about 14 to 15 protocols. We'll continue to add more. As we go through next year, we're also going to be monitoring how many more L2s are coming up. And depending on where we see activity and demand, we'll continue to add it here. It is an open source project, so you're also welcome to contribute. We now have support for all of these chains that you're seeing on screen with our public blockchain data. Some of it is available more natively and some through partners. I do encourage you to look at the partner solutions too, because if you're not building your own data analytics solutions, the partners are providing the data sets for free, but they have fantastic products that help you take advantage of this data and immediately start mining the data with their products. So if you're not familiar with, which I think some of you are not in the audience, with how to handle on-chain data, how to work with it, they've already solved the problem for you. So I highly encourage you to take a look at some of the partner solutions. The most recent data set we added is from Kronos. We do see more demand for more chains coming up, so you should expect us to add more data sets within the next year. And that's the QR code for that as well. Which brings me to partner solutions. So regardless of what you're looking for, whether it's blockchain infrastructure solutions, wallet or custody solutions, data and analytics solutions, these are all foundational pieces. There's a lot more. I could open a blueprint and we could walk through that. There's a lot more, but these are very foundational. And for each of these, we have vetted and qualified several partners who have solutions on AWS, which can help you stand up your decentralized application very quickly, because it takes care of all of the foundational base layers for you. All you have to do is just focus on that application you're looking to build for decentralized technologies. So let's take a quick look at top use cases on Web3. I have a few here. They're not limited to this. I just put it here because these are where we see the most activity right now. Tokenization, trading, payments, and wallets. You're going to actually hear about tokenization payments today in conjunction. So I'm not going to spend a lot of time here. But what I want to leave you with as a thought about Web3 is one of the biggest trends that we are starting to see emerge is around digital assets, tokenizing securities, tokenizing currencies even, stable coins. But all of this does not matter if you don't have a use case downstream to actually take advantage of what is being provided. And that's where payment really comes in, right? So think about one as the enabler, the other as the actual utility that's going to take this more mainstream as we move forward. Here's an up-close look of what a tokenization solution looks like. And don't panic, I'm not going to walk through the solution. What I want to draw your attention here is if you look at an end-to-end tokenization solution and you break down the building blocks of it, you can quickly see we have all the products and capabilities to address each of those building blocks on AWS. And I could just as easily map this building block and show you how our partners play over here, who provides the tokenization engine, who can provide a wallet, who can provide the custody solutions. So the high-level idea I want you to take away from this is not only can we help you stand this up on your own if you want to, we could just as easily help you get moving with partners as well. So think about it as a blueprint that can map to AWS or map to partners, depending on your appetite to build or buy. Now let's take a look at the Web3 trends that are shaping the ecosystem for us. I have a few different bullets here, but I really want to draw your attention to two. That's what we're going to focus on today. There's been a lot of institutional government adoption that we have started to see, which has led to regulatory clarity. So if you're familiar with Genius Act, if you're familiar with Clarity itself, you will know that stablecoins are starting to get accepted more as a digital asset that could be leveraged for multiple different use cases. And we're seeing more informed language from the governments on this one. So we are hearing a lot from our customers. But like I said, issuing a stablecoin is one thing, but actually using it is what matters. That's what really brings it to everybody. And that's where payments come in. So stablecoins and payments, we're seeing it as one trend together, and you're going to hear from Eric and Josh today about what we do with digital assets, how can you actually build a payment solution. Which brings the next question, why does it matter? I already have currency, I already have a payment solution, why does this all matter? It matters because there are challenges with the existing traditional payment solutions. Current payment solutions, there's very high processing fees, there are long settlement delays, there's currency fluctuations to contend with, complex cross-border transactions that need to happen if you're trying to move money from one country to another. And lastly, there's a lot of multiple intermediaries. Take a step back and let's look at it from the other side, right? If the processing fees are really high, it's really hard to do smaller transactions. Digital assets payments actually reduces the cost because there's less infrastructure needed, less fraud management costs, automated compliance. All of this actually reduces the cost, which brings a big benefit, which is micropayments. You could now be paying smaller payments. You could be doing a lot more transactions, right? Again, settlement delays. If you're trying to trade, say, on Monday, you got to make sure you're transferring on Thursday, the previous week, to make sure the money is ready for you to use. Now, if you're a small business and you're contending with 3-4 delays in transaction, it really affects your cash flow. Digital assets settle in minutes. Improving cash flow, improving response time. Same goes for currency fluctuations. I don't think I need to elaborate on that. If you're dealing with currency fluctuations and waiting for money to settle, you could be losing 1 or 2 percentage points if currency is shifting. And intermediaries, right? If we remove the intermediaries, if we reduce the intermediaries, not only does it get faster, it gets cheaper, but more importantly, it reduces the counterparty risk. So there are a lot of advantages that's starting to drive why digital assets payments are going to become more mainstream. The one thought I leave you with is this allows us to bank the unbanked. There are over 1.2 billion people without access to actual banking systems today in the world. This brings banking to them. This brings peer-to-peer transactions. This brings a lot more that they can do. I'm going to now invite Eric to come and talk to you about X402 payment protocol and how it enables digital assets payments. Thank you for listening to me.
Thanks, Arvind. Super excited to be here. This is the first time I've been at a silent disco talk. So if you're in the audience and you can't quite hear me, try the headphones. So I'm Eric. I lead engineering for Coinbase Developer Platform. CDP is kind of like what AWS is to Amazon, CDP is to Coinbase. So Amazon took all their expertise in building cloud infrastructure and made that available to millions of businesses to leverage and use. CDP has done the same with Coinbase's infrastructure around custody of assets, payments infrastructure, blockchain infrastructure, wallets, orchestration, trading, et cetera. There's a bunch of things on this slide that we do that are not even here. Like if you want to talk payments or stable coins or trading as a service, come and talk to me after this. But we also have great wallets. We also have great access to data products. We also have nodes and staking and on-ramping and off-ramping into the crypto ecosystem. But I'm not here to talk about CDP today. I'm here to talk about agentic payments and a project that we've been working on called X402. So broadly at Coinbase, we think that stablecoins are an extremely compelling technological solution for AI. And so by show of hands, who in the audience knows what a stablecoin is? Okay, so probably about 70% of people. Maybe to level set, a stablecoin is a token that exists on a blockchain that's pegged one-to-one to some fiat asset. So the one folks most likely would have heard of in this room is USDC. USDC was a stablecoin launched by Circle and Coinbase in partnership. It's backed one-to-one by a mix of US treasuries and dollars in bank accounts, and it's fully audited. Both Circle and Coinbase are now public companies. You can literally go see every treasury serial number that backs USDC and know for a fact that it's backed one-to-one. So if you're holding one USDC, you can get out $1 into your bank account. Why are stablecoins really good for agents? Well, there's a bunch of factors that I'll get into: cost to transact, speed of settlement. But there's kind of a more fundamental problem that you face when you get into payments, in that there are no open standards for payments. And so let me hit you with a definition. So the internet has existed for coming up on 35 years, roughly, and we don't have a standard for payments. If you want me to go really, really deep into this point, I did a talk on Wednesday on the FSI track, just basically breaking down standards and the reasoning why they're important. So I encourage folks to go check out that recording. But let me define how I think about internet native payments. And so I would define internet native payments as a method for computers to programmatically exchange payment in a standard and neutral way within the existing client-server paradigm that the internet is built on, and without requiring a human to be in the loop. So what do I mean by standard and neutral? It means that every interaction between a client and a server should be the same. We don't download a different browser for every website that we visit. The internet works because the browser that you use that's published by Google can visit a website published by Amazon, and there's an agreed upon standard way to transmit that data. Those standards being HTML, CSS, JavaScript for interaction, etc. Neutral in that it doesn't bias towards any particular payment processor or blockchain or mechanism of payment. Any mechanism that wants to be represented within an internet native standard needs to be able to represent their payment flows within that standard without gatekeeping. And then within the existing client-server paradigm, for those of you who have integrated a payment API before, you'll probably have noticed that at some point the client usually will make a call out to someone else, or there's a webhook, or there's some component that exists outside of the requests the client is making to a server directly. And then, without requiring a human in the loop, almost all payments that have occurred on the internet up until this point have been downstream of a human entering a credit card on a website. And so, if we believe that we're going into an age of agents, we need to break out of that paradigm. And you see remnants of this idea that we need an internet native mechanism for payments all the way back into the 80s and 90s. And so the HTTP 1.1 standard, which I believe was published in 1997, reserved an HTTP status code 402, for future use to represent payment is required to access this resource. In fact, Mark Andreessen, co-creator of Netscape, spent a lot of time trying to make payments on the internet work, but the technology wasn't quite there. And part of the reason we think the technology is there now is the rise of stablecoins. And so 5 years ago, back in 2020, it cost about $10 to send a stablecoin. But while kind of the world was focused on AI and many other things, blockchains got extremely good. And now it typically costs under 1/10 of a cent to send a stablecoin. And that could be a single dollar, or that could be $1 million. But the actual cost on chain to send that money is 1/10 of a cent. And there's no percent-based fee. You're purely paying for the resources on the blockchain that your transaction is utilizing. It kind of breaks, it's unintuitive. Most people are used to, there'll be like a 30-cent fee and a 3% fee. But with blockchains, you're paying for the processing power of the blockchain that you're actually utilizing. And so as blockchains scale and can do more throughput, can settle faster, you can pass on those direct benefits to payments. So AI really forces us to reevaluate internet native payments. AI is being used by hundreds of millions of people every day now, but the number of economic transactions that they're performing are incredibly low. And part of the reason for that is AI agents are fundamentally a program running on a computer. I'm not sure how many of you have written an AI agent. Maybe show of hands if you've written an AI agent. But maybe about a third of people. You will quickly realize when you want to start building an AI that AI is not so different from a while loop that just runs for a long time that makes calls to an LLM. And these agents have no way to consistently transact. You end up with these kind of walled gardens if those gardens exist at all. How many of you, by show of hands, has had an AI agent pay for something for you on the internet? Probably with ACP or some other standard. Yeah. So you're starting to see these standards emerge to address this problem. And ACP is a great standard for checkout and kind of human-in-the-loop conversational commerce. But I think if we want true autonomy, we need these standards of payments to be built directly into the internet. Because AI agents really break the fundamental economic model of the internet. And so if you think about how a lot of the internet works, and has worked up until this point, some merchant is paying some website. That website shows you content and ads for the merchant. You as a user consume that content and that ad, and then at some point you convert and you purchase a good from the merchant. This is, I'd say a lot of how the consumer internet works. And the website is incentivized to publish content because they can serve ads. Those ads convert, the merchant pays. It's a nice closed loop between three actors. What we've seen is that AI removes the ads and hence removes the payments. As more people start to use their chat interfaces to consume the internet, you probably haven't seen an ad from a website that has informed a response from an LLM. And scraping to train these LLMs also results in value being missed by the content publishers. And so you break the circle. So we need a new circle. We need a new economic model for these kinds of interactions. And one of the ways to do this is just directly pay for the content. Skip this loop, directly pay the website. And this is where we enter X402, which is the open standard for internet native payments that Coinbase has been working on. And really what X402 is a bridge between the internet and the blockchain-based payments. It's very distracting to speak when people are clapping. Bridge between the internet and blockchain-based payments. And so you get the benefits of blockchains and the benefits of these sub-cent transactions in the internet. Part of the reason why it's not viable to pay directly for content is because it's really hard to move 30 cents or 50 cents or $1 with existing rails when fees are 30 cents and 3%. As a business, if you're charging 50 cents, you're now getting 14 cents in value, which is a lot of margin to eat. Whereas if you're being charged 1/10 of a cent, well, now you're making 50 cents or 49.9 cents, right? And so what is X402? X402 is an open standard for internet native payments. It hits the points of the philosophy I mentioned earlier in the talk. It started at Coinbase. It was actually created by me. And it's now being moved into an independent foundation structured as a Linux Foundation JDF. So how's it going? So in November, X402 performed 70 million transactions. The growth was pretty startling, to be honest with you. We had this nice 30% week over week growth chart and then hit a huge inflection point in November where it really took off. And of those 70 million transactions, the volume, the number of dollars moved, was actually about $40 million. And so you'll notice that 40 million is less than 70 million. The average transaction size on X402 represented a transaction of roughly 80 cents. And those are transactions you couldn't really do in card rails. And X402 would let you scale up payments anywhere from a cent to $1 million if you really cared to. But that niche of kind of micro payments has really been the product market fit for X402 thus far and unlocked new things that previously weren't possible. So how does X402 actually work? So standard to the existing flow of a client and a server. So a client, a browser, your mobile phone, an LLM, a bot, makes a HTTP request to a server. That server will then respond with a 402 status code, along with a header called payment required, which contains data that conveys how to make the payment. I'll get into what that data looks like in a second. The client then looks at that header and then constructs a payload that represents that payment. How that payload gets constructed, I'll touch on in a minute. Don't worry, I'll get to it. And then remakes that same request, just with a header included in that request of payment signature and then the payload that they constructed. The server now has an option. It can do all the work that it's doing on this slide itself, or for teams that are less familiar with working in Web3, you can delegate the blockchain interactions in X402 to what we call a facilitator. And so a facilitator has a fairly standardized flow of the server will call to the facilitator via HTTP to an endpoint we call verify, and it'll propagate to it both the payment requirements it sent the client and the payment signature the client sent it. And it'll ask the facilitator the question, is this payment going to be valid? Should I actually process this payment? In the happy path, the facilitator will say 200 response, yes, this is a good payload. Will result in you being paid. You should go and do the work that's needed to respond to the client. So this is where the server would do its database queries, its cache lookups, generate a PDF, whatever it's doing as a web server. And then after it's done the work, it will post to settle on a facilitator, again with that payment signature and that payment required data that it gave the client. And the facilitator will handle submitting the transaction to a blockchain. Once the blockchain transaction is submitted, the facilitator will respond back to the server and say, this payment succeeded. And this is actually a blocking operation. With modern L2s and modern blockchains, the processing time to confirm a transaction is roughly 2 seconds. And so you can actually know before you return to the client, I've received the money and it's not a reversible transaction. Stablecoins support refunds, but not chargebacks. And so you as the server can always say, oh yeah, I made a mistake, I'm going to refund to the client. But the client doesn't have the ability to take funds they've already given to you away. And so now that you have your funds, you can return to the client and say, hey, here's that news article, here's that API access that you want. And you do that through a standard HTTP, through standard HTTP verbs. And it works through the entirety of the HTTP spec, just leveraging headers. You can return to a post, a get, a put, whatever you want. So let's get into that payment requirements data structure. So this is the top level of what payment requirements looks like. You have a top level version for the X402 protocol. We're about to release the V2 of the spec. And then a list of payment requirements that we call accepts. So this accepts keyword allows the server to specify multiple ways of payment. So you as a server can say, I support being paid with USDC on Base. I also support being paid with USDT on Solana. And in future, where X402 is going to support fiat methods, you may even say, I support USD on MasterCard or Visa. And then an error to convey error information to the client. And so each one of those payment requirements that in that accepts key is kind of exploded out here. And they consist of a scheme, a network, an asset, a pay to field, and then max amount required, which is the amount to be transferred. There's other fields of metadata there, but those are kind of the most important ones. And so what this can look like is you may return to the client something that looks like what I have on the right, where we're operating on X402 version 1. We accept the scheme exact on base of the asset that is the identifier for USDC, and then I want to be paid to a crypto address. And that crypto address can be any wallet. It could be an exchange like Coinbase. It can be any address that is capable of receiving crypto assets. And then the error, you didn't pay me, payment not included. And so let's talk about the payment payload. You'll notice scheme and network. And the way to think about it is scheme is the logical way that money moves. And so in exact, it's the equivalent of me handing you $1. That's as complex as the interaction is. I've taken $1 out of my wallet and I've handed it to you. You could have other logical ways of moving money. For example, with LLM token generation, you don't necessarily know how much to charge until the generation of the tokens is complete, because LLMs don't deterministically finish. And so you can imagine a scheme that we'd call up to, which says, hey, I may charge you up to $1, but I don't yet know exactly what you're going to be billed. And so pre-authorize me $1, and then after tokens are finished generating, I'll charge you based on the work that I actually performed. And so how you construct this payload is what we call a mechanism. And the mechanism is based on the tuple of scheme and network. And what that means is that the way you perform the payment is decoupled from the network and the logical way that payment is performed. And so exact on base Sepolia works differently than exact does on Solana, for example. And you can optimize the payment flow for the blockchain network or fiat network where the funds are actually going to settle. And so some of our goals for X402 were safety, nativeness, ease of adoption, and neutrality and extensibility. And so on safety, the client holds the logic to construct the payment. The server or the facilitator have no ability to move funds without the client authorizing the funds to move. The server elects which payment mechanisms it chooses to accept. And so someone can't say, hey, I paid you on this obscure chain. Now you owe me services. The server dictates which mechanisms it chooses to accept, and then the client chooses which one it wants to use. Similarly to if you're at a point of sale, it might accept Visa, MasterCard, Amex, and cash. You pull out your wallet, you say, oh, I've got a Visa card, I'm going to pay with Visa. And then the facilitator is not in custody of funds at any point and cannot direct funds and route them in any way. It is simply an abstraction over the blockchain to make it so that servers don't need to run hot wallets and run RPC nodes. They can delegate that responsibility to a facilitator that just manages gas and transacting with blockchains at scale. And so safety for EVM exact specifically, we use EIP 3009 messages, which is a standard in the EVM ecosystem for signature-based transfer. And the result is that the only way funds can move is if the client has signed an intent that the funds can move. Nativeness. So we want to include payments in the existing communication that occurs between a client and server. And so that means that these types need to be represented in a way that are native to the transport. We also decouple transport from how funds move in X402. And so in HTTP, we include payment requirements and payloads and headers in the existing requests that occur. In MCP, we include them in the meta field that exists in every MCP interaction and tool call. And then in A to A, we include it in the metadata X402 payment field. And we try to follow the conventions of each transport that occur. And this is all standardized and documented in the repo. Any person can write a client or a server independently of our reference SDK that will be able to interact with any other client and server because how transport works is as part of the standard. So you can go read the documentation on how X402 works within the MCP context and then write your own client or use many clients that have been written over the last couple months. Ease of adoption. So whenever possible, prevent the need for RPC or GAS on the client. You shouldn't need to introduce new technologies to a client stack. We want as much backwards compatibility with browsers and the existing web ecosystem as possible. And then ensure all signatures and standards and signers in our SDKs adhere to industry standard interfaces. This is a very in the weeds thing, but if there's an existing pattern for representing an action, just use that. Don't invent new things. And then we try to provide middleware for all the common HTTP frameworks. So if you use Express, Hano, Flask, Gin, there's more here that I'm missing, but you can integrate X402 into your existing service as a middleware in one line of code. And then have facilitators, as I've mentioned, that abstract away crypto and make it so that the barrier to adoption is incredibly low. You don't need to learn how to operate a hot wallet. You don't need a node facilitator. You just need a URL to make RPC requests to, and everything happens. And our middleware is abstract that away. You just add the facilitator URL you want to use into your middleware config. And then extensibility and neutrality. This is why we decouple data structure from implementation so that EVM exact can be different than SVM exact. And clients and facilitators have a shared understanding of what to do in that scenario. Similarly to if an image tag is using .png, your server knows how to encode that PNG and your browser knows how to render that PNG. And then we would prefer to be, philosophically, we prefer to be unopinionated and modular versus trying to be full stack and solve every problem. We're trying to solve one problem very well, and things like identity and other aspects in the agentic system, we want to be compatible with those things, not try to force everyone into our full stack solution. And so what does this give us? Well, so this demo video I have here is me using my chat interface LLM to research X402 and the trends about X402 that have been happening recently. And what's unique about this chat interface is it has an MCP tool that gives it access to a wallet with stablecoins, the ability to pay for X402 resources, and the ability to discover X402 resources. And so what you'll see is that it first searches the web to try to research X402, and then it checks what we call the bazaar, which is the marketplace for X402 services, and pays for data from one of those services to enrich the report that it writes about X402. And these funds, and this is the wallet that it has, these funds are isolated to the agent. It has 56 cents in its wallet. It only can spend that 56 cents. Then I have the ability to set permissions on how much it can spend per request or in a session. And anyone could build this experience. This is entirely built off of open standards like X402 and the wallet ecosystem and infrastructure that exists around stablecoins. This experience works on anything that accepts X402. And so if your API accepts X402 payment, this MCP can now pay you for your content. And that's pretty powerful. I think it unlocks a level of agentic use that hasn't previously been possible. Right now, you need to integrate each MCP tool manually. Now, you integrate one MCP tool and it can pay for anything in an ecosystem. And what you get is dynamic agents where the set of capabilities that they have aren't limited to a set of vertical integrations and walled gardens that you as a human have taken and integrated one by one. Just like your browser can visit any website on the internet, your agent can now pay for any tool or service to make it better doing work for you. So now I'm going to pass it off to Josh. Josh is going to show you some solutions on how to use X402 and stablecoins to build payment infrastructure on AWS.
All right, thank you, Eric. So let's start at a high level conceptually, right? We like to think of a stack for building scalable AI payment systems here at AWS. A stack starts with a platform or a foundation. And AWS, as Arvin was talking about earlier, provides primitives like EC2 for compute, or Amazon Bedrock for AI, or security primitives like Nitro Enclaves, or edge services like CloudFront. And today we're going to talk through some of these foundations powering this stack and how to actually build solutions. So on top of this, we leverage open protocols, like Eric talked about, right? So some of these have been around for ages: HTTP, DNS, HTML, languages, frameworks, protocols. And now X402 is an open standard for payment that we can integrate into this and start to use it. From here, we can start to combine platforms, protocols, and build and enhance more advanced services, right? Some of this is middleware, some of these are services as products, B2B products. And so Amazon provides services like Bedrock. We provide Agent Core for Bedrock, which I'm going to talk about in a moment. And we have this whole suite for Agentic AI. Coinbase provides what they call Agent Kit. And Agent Kit is a tool to connect a wallet to an AI agent. And we're going to leverage that today as well. And lastly, all of this enables us to build complex solutions to connect to Web2 applications, Web3 applications, hybrid applications, and agent-to-agent communication that involve payment. So if we start zoomed out, I'm not going to spend a ton of time on this slide, but AWS provides agentic AI solutions across the entire stack, right? So we have infrastructure at the bottom layer, we have development and services for builders, and we have applications. We provide this suite of models, tools, applications, and expertise that can help you get started on your journey in the way that you want to do that. We also provide robust infrastructure that includes custom silicon, data access, and other foundational services. And today, I'm going to zoom into just this middle layer in Bedrock because we're talking about builders and we're talking about adopting these new protocols. So Amazon Bedrock, as a prerequisite before we go into this, is a serverless and fully managed service that helps you build, deploy, and operate Gen AI applications, including agents. Bedrock provides access to leading foundation models from Mistral, Anthropic, Cohere, Amazon, and more. And you can apply guardrails, optimize for cost, optimize for latency, leverage your data very easily. We can use these features for any type of use case, right? Including building and operating crypto-native agentic AI payment systems. Bedrock also includes Agent Core. And so we have these services along the top. These are services to deploy and operate agents securely at scale, right? You can think of this top layer as sort of operationalize and running those agents. So we have runtime, which is a serverless runtime for long-running agents where you don't have to manage the infrastructure for them. Then we have Agent Core Gateway, which allows you to easily integrate MCP servers, APIs with your agents, and provide an easy way to empower them with a large array of tools. And we're going to use both of these services today. And then lastly, Agent Core Browser and Code Interpreter allow your agent to act autonomously in the browser and to execute code on your own terms. On the bottom layer, I think of this as sort of supporting tools, right, that enable these agents. You need identity to build enterprise-ready agents with standard-based authentication. You use things like OAuth with your agents. Agent Core Memory allows your agent to store and retrieve short-term and long-term memory for your agents because these agents are stateless, running in runtime. And we're also going to use this today, right? And then lastly, observability helps centralize your observability stack for Gen AI. Agents, especially payment systems, accuracy and the lack of determinism in LLMs makes it so observability has to have an extra layer in there. So when we use these tools, if we zoom out here, what can we accomplish here? Well, one of the key areas we see in the maturity of AI is the ability to discover and use tools, right? So an agent this could be tens of thousands of tools at the end of the day. So Agent Core Gateway plugs into this ecosystem, allows for tool discovery paired with auth to say which tools can which agents use. And then we can start to leverage tools which can be paid API keys. Maybe you have an existing relationship, a monthly subscription where you have an API key. Maybe you have internal services running on a Lambda function or EC2 server that you want to call. But what we're going to talk about today is this middle channel. Maybe you want the ability for your agents to discover and use tools in the way that Eric showed in his video to say, go see what's available on the internet. Go see what I can use X402 to accomplish my goals, right? So we can take an architecture where we have CloudFront, we use Lambda at Edge to allow that to run functions, and we have content backed by S3 or EC2, and we can create this framework. So today, I'm going to talk about an example of a travel agent AI and the data providers that work with it. So this could be built by a company. We have a hypothetical company looking to serve customers that are building automated vacation packages, let's say, right? So the agent presents a front end to the user, which is the travel agent AI interface, the chat. And the AI can then use Agent Core Gateway to go and discover available tools from an X402 MCP server. So as examples here, right, this agent's going to need a lot of different types of data. It might need to leverage a global distribution system that has hotel inventory, flights, flight prices, availability, seat availability, and more. This may charge in a variety of ways. They could be per query booking fees or challenges. It also might need points of interest, databases, local attractions. These could be per query, right? Send me the review for this restaurant for a penny. These could be weather data to identify delay risks or forecast, or just check if you want to go somewhere sunny, right? So we'll start zoomed out. This is the end-to-end architecture. So in the left side, we have the travel agent AI, and this is going to be powered by a server wallet using Nitro Enclaves from Coinbase, and Agent Kit from Coinbase that's interacting with our Bedrock AI agent. In the middle, we have our data provider or merchant. They're going to be providing the API, or the weather data map services. And then we have the Rails, which is that facilitation layer that Eric was talking about. Since we're going to do crypto native payments, we just look at the foundation first, right? Secure wallets using Nitro Enclaves. I'm not going to spend a long time here, but we do have a blog written with Coinbase on our AWS site, which I can send or share. We have a QR at the end with that. But this is the architecture Coinbase uses on AWS to power their server wallet. When a developer wants to create a wallet or sign a transaction, it's going to follow this workflow through the API gateway. The request is passed to a secure signer inside of this enclave, and neither Coinbase or AWS operators can access those keys. This wallet provides a secure foundation for us to build and enable crypto payments. Now we just have to connect to it. So Agent Kit works with the Bedrock AI agent, and this is the architecture we're going to talk about today. This is the architecture powering that AI agent, and it uses Agent Kit to access that secure wallet. So you see Agent Kit here on the right side in that gateway. But starting up here, there's a supervisor agent, and this could be any multi-agent workflow. This is just an example. We have a supervisor agent running in Agent Core runtime, and it's going to interact with an itinerary agent that manages the memory and planning for the travel. And it's going to make assumptions. It's going to say, we need to find a hotel in this place because we've confirmed that place is good, right? We want to go there, so we want to confirm that we have availability. So it's going to run those assumptions by the tool agent. The tool agent is going to use Agent Core Gateway to look through its available tools. Some of these tools might be directly registered with Agent Core Gateway, but there might be external MCP servers outside of the account, right? This could be X402 MCP servers, or maybe even some kind of universal travel MCP server run by an existing travel company or travel agency. So if we look at the end-to-end path, the tool agent is going to call Agent Core Gateway. It's going to call the X402 MCP server through Agent Core Gateway, and then it's going to access the data it needs, and it's going to pay for it via X402. And it's going to be able to leverage the wallet that it has through Agent Kit, which is also registered to the gateway. So that's the AI agent side, but we can actually go look at the other side on AWS, right? If you are a data provider, let's say you're the service that's providing that weather data, that's providing that map data. Remember, these are the entities that are providing the flight scheduling, the distribution. There's an opportunity for these customers on AWS to also start to monetize their data in new ways for new workflows and not rely on existing bundled and subscription ways to pay for those services using the bridge of X402. So just to put our position on the map here, this is the architecture from the other perspective. We have some overlap with the Agent Core Gateway. We see the same X402 MCP server that we saw previously. This is just to place us. So it has the Agent Kit and the X402 MCP server registered as a tool. Once this passes through that layer, it's going to go through the CDN, which is CloudFront, and it's going to go to a Lambda function that we have here, Lambda Edge, as a viewer request, right? And this viewer request is going to, it may initially not have payment information. So this Lambda function is going to send back a request saying, hey, this content actually has to be paid for, right? So where you need the header that shows that it needs to be paid for. It's going to specify the asset, the network, up to parameters like Eric was talking about, and the client can retry the request. If the payment header is present, it's going to ask the facilitator to verify. It's going to say, hey, is this payment going to work? Is this payment going to go through? Is this address valid? If that's valid, the X42 function can respond back to the server and make the request. And then ultimately, it can, the agent can issue the correct payment. At the end of the workflow, it can forward the request back to the origin, in this case our EC2 web server, that hosts the satellite weather images or JSON weather data or whatever data the travel agent needs. And at this point, the agent has requested weather data. It has been paid for by their connected wallet via Agentic, and the merchant has been prompted for the accepted payment via the export, or has prompted for and then received the accepted payment over X402 into their own wallet. The facilitator handles the settlement and on the blockchain, and the funds arrive in the crypto wallet for the merchant. So we also have some additional resources, blogs, things like that. The Agent Core docs will show you what I was talking about earlier about observability, identity, runtime gateway, and you can get familiar with those primitives. We also have a blog that we've jointly written with Coinbase going in deep into the Nitro Enclaves-based wallet that we used. And we have a link here to CDP's documentation. This covers X402, Agentic, among other services that they offer. And with that, thank you so much for your time. I hope you enjoyed the talk, and have a good rest of your weekend.